that you can actually possibly do with Python. Yesterday, we have seen a couple of examples, but in my experience, having only two examples cannot actually justify or let's say judge the power of Python. Basically, Python can be used for virtually anything. Okay, so in this example, I will show you how to use Python in order to read well-logged data. Okay, so before we go ahead and show you how to read well-logged data, it's very important to understand what is a well log and what it's look like. Okay, so let me just pull up one of those handy PowerPoints that we have that we distribute to our trainees that undergo this training. So basically in in I think it was in 2010 or something that there's a huge library came about, and it suddenly appeared in Python, which is called Lasio. Lasio is actually is an extremely important library in Python ecosystem, and this, believe it or not, this library was created by the Canadian Well Logging Association. So this is not just a library that was put up together by some newbie on the internet that he wants to read well log files. No, this is actually this is the library that you should go to if you want to read well log files. So the documentation is just it just explains everything about well logs. So the important thing about this is actually you should know that this library can be used to read last files from 1.2 and 2.0 versions. Plus, it's used or it's created and maintained by the Canadian Well Log Association or Society. So the well logs are not that special of a data. Well logs, they are just regular ASCII files. An ASCII file is just a file that contains some text, and basically that text is actually viewable on your computer. So let me just show you an example. So on my desktop, I have created a folder. I have called it logs. And in this logs folder, I have added 10 well logs, or at least I think it's 10. Yeah, it's 10 well logs. And those 10 well logs actually, they can be used and they can be opened in Python, or you can just open it in a typical notebook. So sorry, if you go to open, or maybe you'll go to edit, let's just open it with Notepad++. This is just a text editing software. This will actually this will open up. Well, this does not look good. So let me change the language. Yeah, it's a little bit more visible now. So you can see that this log file actually contains all the data that was recorded during the well log operation. Uh, uh, Learning how to read such a file, it's not just about reservoir engineers or petrophysicists want to learn how those files are read. Sometimes you will encounter information that are set within these files. For example, multi-finger caliber, production logging values, or any log. Sometimes even logs that are not related to petrophysics can be found in such files. And to read such a file, you should know the structure that this file was built in. But lucky for us, the days has gone where you have to write everything manually. Now we have ready packages that we can use that can read these types of files in just a single line of code. And let me show you how to do this process. Um, I will show you how to read such a file, how to extract informations, and how to actually start plotting these. Okay, so let's go to our Python. Yesterday, I have been asked multiple questions. What is the software I'm using? So yesterday's software was called Visual Studio Code. Today, I'm using something called Jupyter Lab. So basically, all of these are helpful, and you can use them just depending on what on or let's say on your mood or maybe what you're trying to achieve. But almost all the softwares will do the same thing exactly. Okay, so let's do one thing. So if you want to read those nifty well logs, so what you're going to do is you need to import the Lasio library. The Lasio library is the official library that reads well logs. So let's just give this a nice name. Let's call it LS, or you can just omit this altogether. Maybe this is confusing. That's just enough for now. We can import always something called OS. OS is just a Python library that allows you to interact with the operating system. So that's why it's called OS. Sorry, by the way, I'm a little bit sick. That's why my voice might change from yesterday's. Um, so this is OS. One more thing that you can import is actually the capability to plotting. And one of the most important libraries in plotting, it's called Matplotlib. So let's go ahead and import that as well. So import matplotlib.pyplot SPLT. I know this is mouthful, but you have to memorize this if you want to get good at Python. Okay. And basically, if you notice what I have been coding during those two-day sessions, actually you can see Python abilities that Python or the power that in the Python that we get is actually based on those import statements. So once you write import, meaning that you're trying to get features that does not exist in Python, and believe it or not, those 3 lines, if you try to program these on your own in any given programming language, it will take you years in order to accomplish these features. So that's why Python is so powerful, because everything has been built. It's just waiting for you to use it. Okay. So let's do one thing. We know that we have well logs that are sitting in this folder. So what we can do is we can just copy the path to this folder, and then let's declare or let's create a variable. Let's call it path equals to the path that I have copied, where all of my well logs exist. And we will be doing one thing with the help of the core OS from Python. We will read all of those file names. This step will only read the file names because we want to know what files that we have in that particular directory. So what we're going to do is we will create another variable. Let's call it files. Guys, if my voice is okay, please say so in the chat box. If it's a little bit on the low side, please also notify. Okay, so what we are going to do is we will be using os dot list directory like this. And once you list this directory, you will provide it with the path. So what Python will do, Python will understand that you're trying to know which files do exist in this path. So let me just print the files like this. You can see Python have generated a list of all the last file names that are available in that folder. And if you match it, you will find an exact match of what you have. And basically it's in the same order as your folder. Okay, so what else you can do is there are many things that you can do that we are not going to take a look at this this webinar, because this is just a really small webinar. But the things that you can do is actually you can set different rules and different filters during which files that you want to obtain. Maybe you want to obtain specific files that match a really specific string. Okay, so you can also do that. But for our for our journey now, I think that's just enough. Okay, so what we're going to do next is, once we know the names of the files, the next step is actually to start reading those files. Okay, so how do we read those files? We need to open up a loop or a programming loop that will read all of those files one by one. And please pay attention that the names of those files now are saved in this variable, which is called files. So what we're going to do is we'll create a loop. So for I as an index and value in enumerate files. So in just a second, I will tell you what this will line do. So what this will line create is actually it will take all the files one by one that we have in this variable, and it will substitute it in this variable value. Let's just call this file, okay? And or let's just call this single file for simplicity. And the I is actually the location of that particular file. The location of that particular file will be very helpful when we start plotting. So that's why I am doing it at the first, at the beginning. There are many, many other ways that you can do without this, but this is actually the most elegant approach that you should do. Okay. So let me just create a list that will hold all of my last files. So last files equals to. So those are actual last files that contains the actual values. It's unlike the files. The files only contains the names. However, this one will contain all the actual things. Okay, so let's go ahead and do one thing. So I will create a single last equals to Lasio dot read, and then inside the read function, I will provide the path for this file. So what I'm going to do is I will type os path dot join because I'm combining two paths together. So the first one is the directory and the second one is actually the file name or the single file name. So it will be something like this, path and single file. So what this will do is actually it will generate this path for you and it will read the last file. So the final step is will be to add whatever has been retrieved from this last file into this direct or this list that contains all of our files. So last file dot append meaning that I am adding a new value to it and the value is going to be last, and the value is basically a full-fledged last file. So let me do one thing. So let's just print out whatever well has been finished reading loaded. Okay, so let's call this single file. Okay, so once we have that, let me just run this. Okay, so let's run this. And yeah, you can see now all the last files has started to load. And you can see we have loaded 10 last files actually without any effort. And if you think that you have to write this code each and every time, you might need to think this twice, because this code, once you write the code, you can save it somewhere and then you can just use it over and over again. So this is just a one-time thing. So once you write it, you will save it and then you will utilize it somewhere else. Okay, now since we have the last all loaded up, meaning that we can now start to utilize those last files. Okay, so let me just, before we go ahead and utilize those, let me just show you the contents of a single last file from the perspective of Python. So if you type last.header, you will see all the related informations to that particular last file. You will see the version, you will see the well. You can even just view the curves as you go. So those are basically all the curves that do exist in this last file. For example, we have gamma ray, we have the density, we have the deep resistivity, we have the um, in shallow resistivity. So basically we have SP everything, and we have the caliper. So basically those are the curves. And in order to utilize these effectively, what we will do is there is another thing that we can retrieve is actually the data itself. So the data, you can see those are all the data that are relevant to those last file. But one really, really sick trick that you can do is you will convert this last file into actual table. Once you convert it into actual table, it will be just something that you're really, really familiar with, which is we have seen yesterday, which is a pandas table. So once you have this Pandas table, meaning that you can do anything with this, you can export it to Excel, to CSV, you can compare multiple wells together. So basically you can do anything. So let me show you one of those things that you can do. So if you open up a new programming loop and start to plot all of those, for example, gamma rays together, you can see how different gamma rays from different wells can be put in a single plot. So let's do this for las in las files, something like this, because we have this las files that contains all of our las files. So what we are going to do is we will be just creating a plot. So I will create a figure that will hold a plot for me. So plt dot subplot, and yeah, that's basically it. So what I will do is I will start plotting the gamma ray that we have in each las file. So before we do that, I will create the table from las.data frame. So this will convert it into a proper table as just viewed below it. Once we convert it to a table, it's actually the plotting process. It's much easier now. What we're going to do is we're going to do something like axes dot plot, because we're looking for a linear plot or a line plot. And so the tricky part about plotting the well logs is actually the y-axis is going to be depth, and the x-axis it's going to be the value. However, if you're working with pipelines, so this is actually the opposite. In the pipelines, the x-axis is always the length, and the y-axis is the value. Whenever we're talking about the profile plot, okay, but in well logs, it's a little bit different. So in the x-axis, I will be using dot gamma ray. So I will be plotting gamma ray. In the y-axis, I will be using dot index. Index means the first column that you have in your file. So this one is actually the depth. And this is how actually Lasio is built. Let me just show you one thing. So if we run this, this should generate a plot for us. And do you know what this is? This is actually 10 gamma rays from 10 different wells, all plotted together, so you can compare everything. What you can do is actually you can limit the gamma ray, because most wells will not just surpass 250 or something, because some readings are just wrong. So let me just limit this by setting an X limit to between 0 and, let's say, 150. So let's rerun this again. And yeah, this is now the gamma ray. You can do lots of things with this. Um, what else you can do is actually you can convert this from a single las file reading into a multiple well reading using the same approach that we did. So what we are going to do, I will delete those two lines. Okay. So what we are going to do is we will, instead of just having an empty subplot with a single plot, we will activate an option called ncalls. Ncalls is actually the number of columns that we want to plot. For example, we will be using the dynamic count or the dynamic length from the last file. So as many files as we have, we will be creating columns. So let me just show how this is going to look like. So figure, yeah, so it's going to look something like this. Okay, so we are going to populate each single track with a gamma ray value from that particular well. Let's do a few more steps. So I'm going to activate the Y sharing, because in the last files, Y axes are always shared among those wells, because there's a common depth or there is a common reference between them. That's why we're doing this. And one final thing is actually, I am going to activate the figure size, because this is extremely important in well logs. Let's put this 18 by 8. So this is width by height, inches. Okay, so let's go ahead and start plotting all of those wells. Okay, so let's do one thing. We will also go back to using enumerate like this because enumerate will help us in index plotting. So I will be index and last will be the last file. Okay. And we start plotting by axis of I. So this is the index of which well we are plotting, dot plot. And of course, let me just put back the table dot gamma ray, which is going to be on the x-axis. And on the y-axis, I am going to use the index, which is going to be the depth. Let's delete this and let's run this. Yeah, you can see now all the last files has been read and it was just showing in this format. Okay, of course, you can change multiple things about this. And you can see there is one really annoying thing, which is actually the y-axis is actually starting from zero and counting up, which is something not usual in well logs. In well logs, we have actually accustomed to reading the well log from top to down, not the opposite. So this is actually can be solved really easily. So we will just invert the y-axis like this, run this. There we go. Now the y-axis has been inverted. Now you can do multiple things with this. Okay, so let me just show you what you can do. You can just limit the gamma ray to any given value. For example, let's limit the gamma ray set X limit to, for example, from 0 to 200. Plus, there is one more thing that we can do is actually we can activate the grid because there is no grid right now in the plot. So let's activate the grid. One more thing that we can do is we can also activate the title. So set title because now each track has a gamma ray value for a given well, but that given gamma ray, it's not indicative of which well it's representing. So if we have a title on top of each well, that will be awesome. So it's going to be something like uh, files of I. Let's run this. There we go. Now we have each well having its own last file on the top. Okay, so now more customization can follow. For example, you can make this green colored. So I'm sorry, you can make this green colored. So color equals to green, for example. You can even change the line width to, for example, to something softer than this because this is a little bit bold. You can see now it's looking better. One final thing you can do is actually you can export this to any place you want. For example, let's just export this to a PDF. This will be fig.savefig. For example, last file.pdf like this. There we go. Now it's also saved in a PDF format. Yeah. So basically there are lots and lots of things that you can do with this. But the most important thing that you want to keep in mind is actually the flexibility of having multiple well logs being read at the same time. So let me just show you what will happen if I copy all of those data and paste it again and paste it one more time. So this will actually generate 30 last files in our directory. So what we're going to do is we are just going to read this from the top. So let's run this application from the top. Now you can see it started to read those last files one by one. And once we have all of these last files reading finished up, we will continue with plotting and actually putting everything together. Okay, so yeah, everything looks good now. Now let's move to the next step, which is actually plotting everything together. Since we have give this an adjustable number of columns, so it will actually detect how many wells we have. There we go. You can see it now has accustomed our application to a given number of curves. Of course, you can just change the figure size to account all of these wells. For example, let's make the width 25 inches. So once you do that, once you make it 25 inches, actually the plot will be a lot bigger now, and it's going to be a little bit more visible. You can, if you want, you can just copy this as an image. You can save it as a PDF. You can do basically everything with it. If you don't want to see, for example, gamma ray, you can change this to any variable you want. One more thing that you can do is actually you can, in place, you can just calculate the shale volume that we have for all of these wells. So let me just show you how to do that. So I will create a variable called vshale. So this is just for you to see how simple it is. So the vshale, I'm going to use the linear equation. So the linear equation is really simple. Uh, the linear equation, actually, it's the maximum shale reading. So table dot gamma ray dot maximum reading, and that's it. This will find the maximum value of your shale, minus table dot gamma ray, which is the reading from the well log, over delta gamma ray, which is the difference between the maximum and the minimum. So table dot gamma ray dot maximum, subtracting table dot gamma ray dot minimum. Believe it or not, this is all the equation that you need. Now, this gamma ray, or sorry, this linear V-shale index is just a linear. There are multiple versions of this V-shale calculation, but you can just apply whatever equation you want. And the most important thing, this equation, it's not a static equation, or this is not a static expression, because the maximum and the minimum gamma ray will be evaluated based on whatever well log file that you pass through this loop, meaning that it's not fixed. Okay, so instead of just having gamma ray, we will be using vshale as a plotting technique, or as a plotting variable. Plus, let's multiply this by 100. So this is going to be ranging from 0 to 100% shale volume. Let's run this again. Let's wait for a few seconds, and there we go. Now this is basically the volume of actually the shale we have. Let's change the X limit to actually to from 0 to 100, because now we are working with shale volume between 0 and 100. There we go. Now you can see most of the time the shale volume is really, really high. So basically, yeah, this is basically how to calculate the gamma ray shale volume based on the gamma ray. You can also use other equations. Okay, so this is the first part. There is one more thing that you can do is actually let's move to another topic, which is actually not having enough knowledge about Python to create graphics or to create visualizations. And people in Python, or let's say Python community, have noticed this issue. So what they have done, they've introduced a product called MitoSheet. A mito sheet is just something that's extremely similar to Excel sheets, but it will, sorry, it will open up in a Python application. Uh, being a Python application, meaning that you'll have really, really high customization, customization um, chances. So let me just show you one thing. So I will import pandas as PD. I will read a file from my desktop. Let me just bring up a file. And that basically, that particular file will be used. Let's search for txt files. Let's see what it is. Yeah, let's just get this one, get this file. Okay, so let's do this. Yeah, let's read it. So data frame equals to pd dot read underscore csv, file and separation of tabs. Let's print this back and let's see what data that we will get. There we go. Now this is all the data that we have. What can we do is, instead of just taking a look at those static data, We can just convert this into an interactive sheet. How can we convert this interactive sheet? We will insert or click this button, insert my to sheet. So once you insert the my to sheet, and you will type inside this the name of the table that you want to work with. For example, I am working with data frame. So let's press enter and wait for a few seconds. There we go. Now you have managed successfully to convert your data from a boring static data into an actual table that you can interact with. You can filter this table based on a given well. You can create plots. You can replace values. You can do any sort of filtering you want. For example, let's do a simple filtering. Let's do a string filtering or sort this ascendingly. And you can see once you sort this, there is a new code that is generated. Basically, you can take this generated code and use it on your own. This is not using any form of artificial intelligence. This is just this is how this program or how this um, table is structured. The actions that you will make, it will be converted into codes that you can just copy and paste and use anywhere. Okay, so for example, if you don't know how to create uh, uh, or let's say, let's change this data type to, for example, to string. So once you convert this into string, a new line of code, it will open up and will show you that you have successfully changed this to a given value. Let's convert this to an integer. Yeah, so once we do that, there will be a new line saying that you have actually changed this from actually float to integer. So yeah, more things that you can do. You can just insert plots, you can just create graphs, and this is also done virtually. One more thing that you can do is actually you can pass multiple data frames to this. For example, if you pass two data frames or two tables to this, it should render a page with two data frames. There you go. You can see now you have two data frames to choose from. You can just keep one of those for experimentation and keep the second one for actual use. Okay, so this is how to actually to deal in a graphical interface in some of the data filtering and data management in Python. One final thing I will show you is actually how to basically how to create some simple maps in Python. So let me just delete those. And since we have read all of these files, we can actually convert this file into some form of a map. So let me just do one thing. So import Plotly Express as px. Okay, so Plotly Express will help me to actually locate the X and Y locations of those wells. So let's run this. Since it's run fine, let's move forward and start plotting the X and Y map, which is going to be a really simple plot. So px.scatter, we will pass the data frame, and the x-axis is going to be actually the data frame dot columns. Let's see what columns we have. We are going to use the bottom x, and the y-axis, it's going to be the bottom y. So this will actually will show us the locations of those wells in a given map. And yeah, so the text, it's going to be actually the name of those wells. So let's run this. There we go. Now you can see we have successfully converted our data into a plot, which shows the location of X and Y. There is one thing that you can do. Let's use a template that will beautify our plot. A template of none. There we go. You can also color this by the name of the well or even the type of the well by adding the color unique ID. There we go. Now you can see all of those wells has been colored properly. You can change the size of this. For example, let's apply a width equals to, for example, let's say 1,000 and a height of 800, for example. Run this again. There we go. Now this is how your map is looking like. Of course, you can just zoom at any location in your map, and you can, of course, get the coordinates for that. This is just how X and Y maps are created. Uh, what you can do else is actually you can create contour maps as well. Contour maps are best done using Matplotlib because Matplotlib is extremely fast at creating, let's say, maps. So let's import matplotlib.pyplot ASPLT. Uh, so the map plt dot contour map actually takes three inputs, which is the X, Y, and the Z values. So in this instance, so the X axis, it's going to be bottom X, the Y axis, it's going to be bottom Y, and of course the Z axis is going to be depth, or it can be porosity, saturation, density, or whatever you want. I will be using the total depth, so data frame dot t depth. So if you're wondering where I am getting this name from, so basically those are all the columns that do exist. Let's run this. Okay, so we're getting an error. It must be two-dimensional, not three-dimensional. Okay, so contour. Okay, so we're missing something. So it's try contour. Yeah, there we go. Now this is how your contour map is looking like. Of course, you can change the colors as well. So if you use a color map of, for example, rainbow, you will see that the colorings now are different. Okay, one more thing that you can do is, of course, you can just uh, make those observations between those different contours more visible by adding another layer. So try contour. I will just replicate those informations like this and rerun this again. There we go. Now you can see it's a little bit different now. There are more things that you can do. You can add a title, you can add a grid. So let's activate a grid. There we go. Let's activate well locations by adding plt.scatter and adding the X and Y of those wells. So let me just copy those, run this again. There we go. Now those are the locations of the wells. They might seem a little bit ugly. So let's change the color to black and the shape. It should be, let's change this to an upward triangle. Let's run this again, and there we go. Basically, this is your map. If you want to limit this map to a given X and Y coordinates, that is also possible. If you don't like how this map is just a static image, that's also a thing. You can activate a matplotlib qt, which will open this in an external window. There we go. Now this is the external window, which is a little bit more higher in quality. Plus it's interactive. It will allow you to zoom. It will allow you to do different things. Of course, the more points that you have, the more higher quality the map will look like. So the important thing is actually this is interactive. So yeah, it's time to conclude this webinar. We have seen multiple use cases. We have basically seen three use cases today. And yesterday we have taken a look at two. Plus, we have already known or we have already seen what Python can do. So this will conclude today's webinar. Please